Hi, 8th graders. We are going to be doing 10.4, 0 and negative exponents. This is kind of a fun little lesson. So go and get out your notes. Remember, you can pause this video whenever you need. If I go too fast, rewind it. But please fill out all notes with me. You also should have had a bell ringer when you first came in, so make sure you have that as well. All right, so the first thing I want us to do is look at some of these like definitions and some of the rules. So at the very top, I know it's very small on your paper, but I do have some rules. The rules of zero exponents. For any non-zero number, like for example, like the base number has to be bigger than 0. So it's got to be 1 and above, right? So anything that's not 0 for a base number, but it's raised to the 0 power, it will always equal 1. The power of 0 to 0 is undefined. There's no such thing as 0 to the 0. Okay, so basically what all that means in words then is 4 to the 0, anything to the 0. 6 billion to the 0, it doesn't matter. It'll always equal 1. That's it. Anything to the 0 besides 0 is 1. But over here, let's go ahead and say a to the 0. If a is greater than 0, it'll always equal 1. But here's what I want you to write underneath here. I want you to say 0 to the 0 equals undefined. Okay, so 0 to the 0 is undefined. Anything that's bigger than 0 then to the 0 is 1, always. Kind of fun. Now let's talk about negative exponents. For any integer, n, and any non-zero number, a to the negative n is the reciprocal of a to the n. I know that's weird. I know that's chaotic. But what they're saying is, take this, and this is how I remembered it as a kid. Take the negative that's in your exponent, turn that negative into a fraction bar, and then put a 1 above it. Basically, 4 to the second could be written as a fraction as this. The reciprocal of that would be 1 over 4 to the second, right? So that's why they talk about reciprocals. Super weird rule, I know, but take the negative, make it into your fraction bar, and put a 1 above it. And now you have, here's your final answer, ready? 1 over 4 to the second. So anything that you have that's negative right here, you're going to turn it into a fraction. Here's another way of thinking about it in algebra terms. It's going to be 1 over a to the n, okay? A can't be 0 though, guys. A can't be 0. That would be undefined. Okay, so now let's go through and do some of these examples. Evaluating expressions. Here we go. I've got -2 to the -5th. Now, before I can do any solving, I've got to turn this into my little fraction, right? So what I'm going to write first is I'm going to just put in parentheses -2 to the 5th, but that negative is now my fraction bar. Crazy, right? Okay. All right, sorry, I had to pause the video. All right, so now we're back to solving. Here's what I want you to do next. Set it equal to, and I want you to actually think about it this way. You don't have to solve it this way when you get good at it. This is more just so you guys can think about what this is actually saying. This is saying this is 1 over -2 to the 5th, in parentheses is -2 times -2 times -2 times -2 times -2. Let me extend my little thing over there. Okay, so now -2 times -2 would be +4. Another +4 over here, so it'd be 4 times 4 is 16. 16 times 2 would be 32. And then it's an odd number of negatives, so this will be 1 over -32. And that is your answer. You can literally just, that is it. There's nothing else you can do to that. Okay, let's go ahead and look at the next example. I have 4 to the 5th times 4 to the -3rd. Oh my goodness. Divided by 4 to the 2nd. So once again, here's what I want you to do first. Deal with that negative exponent first, okay? This one's a little chaotic. So if I think about it this way, this is going to be 4 to the 5th, which is 4 times 4 times 4 times 4 times 4. And then I want to times that by the reciprocal of this, which would be 1 over 4 to the 3rd, which is 4 times 4 times 4 times 4, right? I'm going to put this in parentheses because that's kind of like its own thing. And then we're going to divide that by 4 squared, which is 4 times 4. Now, if you remember, we had a bell ringer a few days ago that had examples like this. And I think a lot of you actually solved them, but you have to remember, if you are multiplying and I have a number on top of a number like this, those are actually equal to just one whole. So can't I cancel both of those out? Yeah, which actually now is great because now my denominator is completely gone. So I'm going to rewrite what's actually happening down here. Now I've got 4 times 4 times 4 times by 1 over 4 times 4 times 4. To multiply fractions, can't I turn this into a fraction as well? And look at how crazy this is. My problem is now going to be going this direction because I'm running out of space. This is actually the same thing as 4. Oops, let me get my black pen. 4 times 4 times 4 times that 1 on top. All of this, oops. This is 4 times 4 times 4 times 1, which is just 4 times 4 times 4. This is 4 times 4 times 4 times 1 as well. So don't I just have 4 over 4 over 4 over 4 times 4 times 4? Didn't I just say a 4 over 4 is one whole? If all of those cancel out, what do I have left? 1. Pure chaos, all for it to equal 1. Okay, so to make this make more sense to you, I like to turn them into something like this where I can see the 4s physically. It's really easy to do that if your exponents are smaller like these numbers are. However, if this was like 4 to the 98th and then 4 to the negative 16th, then it's not so nice because you don't want to draw, that many 4s. But when it's little numbers like this, do this so that it makes sense to you, okay? Okay, let's move on. Simplifying expressions. Okay, so now this is a totally different thing. Up here, we were evaluating the expression, and now we're going to simplify it, which means it probably won't equal a nice, cute little answer like 4 or 1, but we can try to make it look the nicest we can. Now remember, this is actually 8 to the 1st times x to the negative 2nd. Don't get confused and think this is 8x to the negative 2nd. It's just 8 to the 1st and then x to the negative 2nd. So here's what I'm going to do first. I'm going to just rewrite that so that I know this is 8 times x to the negative 2nd. So it's not like the 8 is being, compromised by that negative. Negatives turn into fraction bars and make into a fraction. So I'm just going to leave the 8 how it is. This is just 8 times 1 over x to the 2nd. Now to multiply these two things, I have to turn the 8 into a fraction. So I'll just put it over 1. And now multiply your tops with your tops, your bottoms with your bottoms. 8 times 1 is 8. 1 times x squared is just x squared. And that is your final answer. You can't get anything more simplified than that. That's it. Okay, this next one. I have z to the 6th and 15z to the 9th. All I really need to do on this one, because there's no negatives, there's no zeros. So all I really want to do is just think of it this way. If I have z times z times z times z times z times z, there's 6 of them, right? Over 15 times z 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 times z. Is that 9? 1, 2, 3, 4, 5, 6, 7, 8. Oop, 9. Okay. Like I said, you don't always have to do it this way because you do remember the rule that you can take just 6 minus 9 or 9 minus 6, right? But I want you to do it in your notes this way just so you can physically see what's actually happening here. A z over a z, that's one whole. A z over a z, that's one whole. A z over a z, that's one whole. So keep canceling out z's until then you're done, right? So I'm done. I don't have any more z's to cancel out. Now, if there's nothing left up here, you have to keep it as a 1, okay? because you can't just have like a fraction bar with some numbers underneath it with nothing up here. If there's nothing up here, that means it's all 1, okay? So now my final answer is going to be 1 over, I can't cancel out the 15, so the 15 is staying put. How many z's are left? 3 of them, so I'm going to say it's 15z to the third. And that is your final answer. Okay, last one. Using order of operations. Oofta, this big boy looks intense and a little scary, but don't worry, we can do it. First thing I want us to look at is I've got that negative exponent right there, right? That's going to eventually turn this into a fraction. But what I would like you to do first is just rewrite this with that as a fraction in the denominator. So what I mean by that is this. I have 1.5 squared on the top. That means the top is just going to be like this. Okay, 1.5 times 1.5. Now on the bottom, I've got 1.5 to the negative second. So make that into your little fraction, right? So I've got 1 over 1.5 times 1.5. All of that, then I'm going to times it by 1.5 times 1.5 times 1.5 times 1.5. Woofda. So basically all I've done is like spread it out like jam, right? Now I've got this big long equation. I can see very clearly that I've got a 1.5 and a 1.5. These ones could cancel out. These ones could cancel out. So I'm going to do that. When I do that and there's nothing on top, there's now technically just a 1, okay? So now I'm going to rewrite it as 1 over, and now rewrite what I still have going on. I have 1 over 1.5 times 1.5 times 1.5 times 1.5. I can group these two things together and make them into a fraction like this. And then I can multiply boop, boop, tops, tops, bottom, bottoms. That would end up with, here, I'm going to draw another arrow. We're going this way now. We're running out of space. That would now be 1 over 1.5 times 1.5 times 1 is just 1.5 times 1.5 over 1.5 times 1.5. Oh my gosh. Doesn't this equal 1? Wow. 1 over 1 is equal to just 1. Double check my answer. Number 16 is 1. Yeah. Isn't it crazy how it looks so intimidating and then we just end up with a 1 at the end? That always drove me crazy when I was a kid. Okay, I know this is really complex and I know this is tough, but if you have your rules from the lesson, I am doing this in the future. So, I mean, we haven't even taught this lesson yet. But when we learn this lesson, it'll definitely help when it comes to things like the variables up there, because what you can do to these two variables is just subtract them. So during this, you technically don't need to write that many z's, right? You can just subtract these two z's, and then that'll simplify it a lot easier for you. So don't panic. I know this looks chaotic and hard, but if you have had this lesson, 10.3, it'll make this not so confusing. I just wanted you guys to write it out like this for now, because it also helps you clearly see what technically is going on, right? Okay, hopefully that made sense. I know it's kind of a crazy one. You guys should have a bell ringer with this page. There will be no exit ticket, however. I just want you guys to make sure you have these notes filled out. Now, something very important to know is that you do have a quiz Thursday. So if I were you, I would go in your book, go to section 4. It's what we just did. And there's the quiz right after section 4. Okay. Well, technically it says 1.3 and then there's a quiz. That's okay. Here's the quiz. So find surface area of the prism. I've got this guy and this guy. Find the surface area of the regular pyramid. Oh, wait. That's why this is so confusing. This is the 7th grade book. I apologize. Let me get rid of that. I can fix this. Don't worry. Haha. Okay. This will make much more sense now in my mind. I was a little confused. 10.4. Here's the quiz. Okay. Write the product using exponents. All you have to do on this one is just write -5 in parentheses to the 1, 2, 3, 4. This would be 7 squared times m to the third, and an even shorter way of writing that would be 7 squared m3. Yeah, easy, right? I want you to go through this quiz. If you have extra time in class, like right now, and you the bell hasn't rang, you got like 20 more minutes, I want you to go through and do these practice problems on your own and see where you get stuck, and that will be a good indicator of what you need to practice more of for the quiz that is on Thursday. All right, bye guys.